Hi guys, I'm Bethany. Today we're going to talk about different ways we can represent how a reaction is occurring. We have 3 different types of chemical equations that can explain these reactions. The first is molecular, the second is the complete ionic, and the third is the net ionic. So first off, let's look at this example. We have a reaction where silver nitrate is added to sodium chloride. Represented here, we can look at the cation, silver, with its respective anion, nitrate, and then we have sodium and chloride. Sodium being the cation, chloride being the anion. So the first thing we're going to want to do is predict the products for this reaction. And how we're going to do that is we're going to pair the cation for this first reagent with the anion for the second reagent and vice versa. So sodium or silver will go with chloride in the products, and sodium will react with nitrate. So we have our products here now: silver, chloride, and sodium nitrate. One thing you want to make sure you do when you're writing these chemical equations is you want to make sure you have the right phase. And this you'll do using your solubility tables. So silver nitrate is going to be aqueous. In a water solution, it will exist as cations and anions. So will sodium chloride. Whereas if you look at your solubility table, silver chloride will actually precipitate, so it will be a solid, and sodium nitrate will be aqueous. So this first equation is your molecular equation. Now you want to make sure that your molecular equation is balanced, that you have the same amount of silver ions on the left as the right, the same amount of nitrates on the left and on the right, the same amount of sodium on the left and on the right, and the same amount of chloride on the left and on the right side of the equation, which in this case we do, so we're good to move forward. Our next equation is the complete ionic equation. When we put our compounds into solution, we want to see if they're going to break apart into their respective ions. And we've already determined that silver chloride is the only one that will precipitate or form a solid. The rest of these compounds will break apart into their respective ions. So complete ionic equation is just showing this. So complete ionic equation, we'll want to write the ionic form of each member of these compounds. So we have silver and nitrate, which break apart in solution. So do sodium and chloride. And then these will form our precipitate, silver chloride, and then sodium and nitrate will break apart in solution. So this is our complete ionic equation. Alright, lastly we're going to talk about the net ionic equation. The net ionic equation shows the actual participators in forming this precipitate, forming this solid. Spectator ions are ions that don't participate in the reaction that forms the solid, and then the other ions are the key players in that reaction. So if you look, your solid is silver chloride, so silver and chloride are the only ones that are going to participate in forming the solid. The others, silver and chloride are the ones participating to form the solid, and sodium and chloride are not participating in this reaction. So in our net ionic equation, we merely write silver plus chloride produces silver chloride precipitate. And you want to make sure everything is balanced, and there you have it.